All right, so today we're going to take a look at a couple of weirdos that weren't covered in the original packet. So we're going to start with decomposition, and if you remember with decomposition, decomposition looks like this. We have something, and all we do is just break it apart. Easily enough. And I remember when I sat there and showed you this, and it breaks apart into two individual things. This is an example of decomposition. The problem is that with some decompositions, they don't break apart evenly. So the three that we're going to look at specifically today are a metal with CO3, that's carbonate, a metal with hydroxide, and a metal with ClO3 or chlorate. So when we say metal here, we can put any of the metals from the periodic table into that space, any of them. Now, how do they split apart? It's unique for each case. I'm going to draw them right here, and then I'll give you an example underneath it. So if I have a metal, any metal with CO3, they always break apart into a metal oxide plus CO2. I underlined the wrong thing here. It should be this metal right here. So depending on what I put the metal in here, that's always going to form the same thing. So for example, if I used calcium carbonate, so CaCO3, what is it going to break apart into? Well, the carbonate will always break apart into the metal oxide. What's my metal here? Calcium. And remember, I'm balancing off the charges, so I'm going to go CaO plus CO2. True story? And it's balanced, by the way. Now, if it had been a K, for example, right? K is a plus and CO3 is a 2 minus, so you see how I would have had to go K2 CO3. So I'm going to put this over here as our go-to when we look back at it. So we have MCO3 will always go to MO plus CO2. Okay? What if we have instead a metal hydroxide? Now, metal hydroxides, again, it's a metal with hydroxide. And it will also break apart into a metal oxide, but here we have H's and O's, and so oddly enough, it forms H2O. Same exact deal. Whatever the metal is we put in here, we balance it off with the OH, and the same thing happens over here with this O. So if we take a random metal, and again, I'm going to take a random metal, like calcium, not so random, but if I do calcium, it's going to be CaOH in parentheses 2. That parentheses is important. That's because calcium's a 2 plus and hydroxide's a minus, yeah? That's going to break apart, and it's going to form calcium oxide, again, 2 plus, 2 minus, I just put them together, plus H2O. Now, in this case, we have to take a look and see whether we balanced off everything. I have one Ca, 2 O's, 2 O's, and 2 H's. So again, fortunately enough, we balanced everything off. The last of the three is a metal chlorate. So again, the metal is going to go in here. Here's a chlorate. It is the only one that forms something kind of different. It forms a metal chloride plus oxygen. Again, depending on what metal is in here will determine what gets balanced off here. So if I took my sturdy old calcium, right, and I went calcium ClO3, remember parentheses 2, because this is a minus and this is a 2 plus, I'm going to end up with CaCl2 plus O2. Now, is this balanced? 1 Ca, 1 Ca. Yep. 2 Cls, 2 Cls. Yep. 6 Os and only 2 Os here, so to balance, I'd have to put a 3 here. So those are the three main break aparts. But there's also an added bonus one is when we're dealing with acids. So let's take a look at this really quickly. So quite simply, whenever we have an acid, and remember acids are things that have hydrogens in the front, and there's only two real examples I'm going to give you. One is H2SO3, and the other one is H2CO2. These are going to just lose water. And what I mean by that is literally subtract H2O from this right here. So when I subtract H2O from this, I'm just going to write what's left over. So if I take away 2 H's and 1 O, I'm going to have SO2. If I take an H2O out of this, I'm going to have CO2. So these are two examples. Whenever you see an acid, and again, if you just see an acid, it might say heat, a little triangle over the top, or it might say heat over the top of it. You're going to break them apart by just pulling out the water. Now, you need to remember that you'll still have to put all the names of each thing in here. This is going to be sulfurous acid. And now, this is interesting because don't I have two metals together? And whenever I have, two nonmetals together, whenever I have two nonmetals together, remember we use the prefix naming system. So this would be sulfur dioxide plus water. You could also call it dihydrogen monoxide. Anyway, that's what we are going over today in class. Hopefully this is helpful.